So we're talking about matter today, and matter, as we said before, it would probably be really good if you guys just took this little flowchart and put it in your notes now. You might want more space than I used, like a whole page. I don't know why I squished it in there. Anyway, matter is anything that has mass and occupies space. We've said that like 3 times already. And matter can be classified as either pure substances or mixtures, and then the pure substances can be further classified as elements or compounds. The mixtures can be categorized as heterogeneous or homogeneous. So let's take a look at what these things are. First of all, a pure substance is a single substance that can only be separated by chemical means. So pure substance over here, all right, it is a single substance. And it can only be separated by chemical methods. I'll get my hand out of the way in a minute. Okay, so pure substance. I should have different colored pens, but I don't. It's a single substance, and it can only be separated by chemical means. If we go over onto the other side, a mixture is 2 or more substances that can be physically separated. Okay, 2 or more substances that can be physically separated. So let's talk about a physical separation. If you want to separate M&Ms by color, what are you going to do? You're going to have a bowl or a cup or something for each color, and you're going to put all the red ones in one bowl and all the green ones in one bowl and all the brown ones in another and all the yellows in another, all the greens in another, unless I already said green. But that's a physical separation. If you want to separate rocks from sand, you might use a sieve, something that would let the sand go through it and keep the rocks on the top of it. And you'd be separating by size in that case. Those are all physical separations. Chemical separations are a little bit more difficult. For instance, a compound, let's define that first, 2 or more substances, which I think we've done this already, 2 or more elements bonded together. Okay, so a compound is 2 or more elements bonded together. It can be separated by chemical means, however. So if you took water, which is a compound made of 2 hydrogens and 1 oxygen, and you pass electrical current through it, that says electricity, you will get hydrogen and oxygen. That is a chemical separation. Elements are the smallest unit of matter that you can have that maintains the property of that matter, and they may not be separated by any chemical means. Okay, not be separated by chemical means. Whoops, chemical means or methods. So if you had an oxygen atom, or let's say a neon atom, you can't just chop it in half. All right, that's not going to work. So no separation of these guys. Now, if we go back over here to mixtures, okay, so matter, the pure substances are pretty easy to define. You're going to find elements on the periodic table, and compounds are going to be 2 or more things from the periodic table, making up a formula. So heterogeneous mixtures and homogeneous mixtures. Heterogeneous mixtures have obvious differences. Okay, obvious differences in them that you can see with a naked eye. Vegetable soup is a heterogeneous mixture. You can tell the tomatoes from the green beans, from the celery, from the whatever else is in there, the squash, okay? The M&Ms I talked about before were a heterogeneous mixture. They're all basically the same thing, but they all look different because they have different colors. And then you have a homogeneous mixture. You're probably familiar with the term homogenized when it refers to milk. Milk is made up of proteins and butterfat and water and sugars. And when it goes through homogenization, all of those things stay together and they don't come apart and the milk looks uniform. And that's exactly what a homogeneous mixture is. It's a mixture with no obvious differences. Okay, mixture with no obvious differences. It's going to look the same throughout. Okay, an example of that might be sugar and water. Once the sugar dissolves, you cannot tell there's sugar in it by looking at it. Another example, like I mentioned earlier, is milk. Another example of a heterogeneous mixture is 14 karat gold. It is not pure gold, it's 14 parts gold and 10 parts something else, but you can't tell that by looking at it. So what you guys are going to do is you're going to be soon in lab separating a mixture based upon the physical properties we talked about the other day. So that's it for types of matter.